Welcome to 2-7. This is explaining addition and subtraction related facts. One of the things we're going to be using here is what's called an addition triangle or a fact triangle. We can use these for addition and subtraction. We can also use it for multiplication and division. The form of it is important. The peak of the triangle, which is where this 14 is here, that's the sum. That's what it all equals, right? And then the addends are the things being added together. So 6 plus 8 is equal to 14. So this is the fact triangle being written up to show this. And we see that for this problem, there are in fact 4 facts. Count them. 1, 2, 3, 4. Yeah, I see 4 of them right there. 4. When we say there are 4, when we're asked to write it in different ways, 6 plus 8, which equals to 14, is the same as 8 plus 6, which equals 14, which means I'm using the commutative property of addition. But I have rewritten it in a new form. It's a new fact that I have, that in fact writing it that way gives me the same thing. Now for the next two, the subtraction problems, I subtract the addend from the sum, and that gives me the other addend. So 14 minus 6 will equal 8, or 14 minus 8 will equal 6. So here we have the 4 math facts related to this equation. And these math facts are helpful when we want to look at solving for unknown values in an equation. It gives us some tools to understand how we might manipulate these. Next page is we want to look at the addition property of equality. For the addition property of equality, this tells us that if I have two values, a and b, and they equal each other, then if I add c to both sides of the equation, in fact, it's still equal. It hasn't changed the equality there at all. It just simply has put it into a slightly different form. And the expression may in fact add up to something different, but it does mean it's still equal. Let's look back up here at this property we have. We had 4 plus 3 is equal to 7. Well, 4 plus 3 indeed equals 7. We now add 5 to each side of the equation, so 4 plus 3 plus 5 is equal to 7 plus 5. So we've taken something that's equal, we've added something to both sides of the equation, and now we see that 12 equals 12. The result of the equation is different, but it has maintained its equality through this procedure that we've gone through. That's what the addition property of equality does for us. The subtraction property of equality allows us to do the same thing. We can subtract an amount from both sides of the equation. We have to pay attention to the order of operations and make sure we get it right. If a equals b, then we can subtract c from a. We can subtract c from b, and we end up with the same with an equality. We end up with it being equal. When we look at this from the related facts property of addition and subtraction, if we have h plus m equals s, that's h plus m equals s. We can subtract m from both sides, so m from h plus m just leaves me with h, and m from s leaves me with s minus m, so I end up with h equals s minus m. Or I could do it the other way. M would equal to s minus h. That's 2 of the 4 related facts for subtraction, which leads us to our related facts property of addition and subtraction. Using a fact triangle, we can see that a plus b is equal to c, that b plus a is equal to c. That's 2 facts. Excuse me. And then c minus b is equal to a, and c minus a is equal to b. That's 2 more facts. That's 4 math facts from this one equation. I'm going to go through a few extra examples. You can take a look at the examples in the book yourself. I'll be presenting a few in just a moment. But take a look at it. If you need some more help, take a look at the ones I've done for you. Have questions, talk to each other, ask questions of each other, put them on the board, bring them to me. We'll see what we can do to help out. Well, here we are on 2-7, explaining addition subtraction related facts. I've got a few additional examples about how to use the fact triangle to solve for a variable. And we're going to take a look at our first one. Here's the first example. And this is extra example 1. And what we're looking at is y plus -3 equals 21. Well, we want to fill in our math fact triangle with the appropriate values, and our addend, or our sum, excuse me, is right up here, so that's 21. And we're going to put in a minus and a plus, so it'll be what's down here, y plus the other addend, -3. And that then gives us the information we'd like to see for the math fact triangle. Now, can we use that to find a fact that would help us figure out what y is? Well, we know that two of the facts are that y plus a -3 is 21. We know that a -3 plus y is 21. That's the two math facts, and that doesn't really help us. What we want are the subtraction ones, and so we want to end up with y. We want to know what y equals, and y is going to be equal to 21 minus a -3. -3 is a number. That negative is not a subtraction sign. And so 21 minus a minus it's a double negative, so that's going to be a plus. So y equals 21 plus 3, and therefore y equals 24. So we have just solved an algebra equation for a variable and shown that indeed y equals 24. That's it. We used a property here. We used the subtraction property of equality, which allowed us to subtract a -3 from both sides of this original equation. We went here, we did y plus a -3 minus a -3 equals 21 minus a -3. And this is the subtraction property of equality. This is an algebraic property. When we're going through and showing our work, this is part of showing your work, is showing this kind of a step. We now can see that y, a -3 minus a -3 is just 0, so y plus 0 is equal to 21 minus a minus would be 21 plus 3. Y plus 0 is y, and y equals 24. So here we are with this first example. We've used the math fact triangle to represent an equation where we had an unknown in it. We wanted to find out what the value of the unknown was. Let's take a look at another one. We'll go into another problem here and see what we can do. Okay. Oh, here we go. Extra example 2. Here we've got 4.7 minus a equals 5.3. Okay, what goes into the top of the math fact triangle? No, you tell me. I'm waiting. What? What'd you say? Oh, you said that it's what that whole thing equals, but it's a subtraction problem, isn't it? So how are we going to deal with that one? Let's see. Well, we need it to be an addition problem, don't we? Because that's a problem for us right there. So let's see what we could do. We could use the algebraic definition of subtraction, and we could change it into an addition problem. You good with that? Okay. So that would be one thing we could do that tells us that 4.7 plus the opposite of A equals 5.3. So here we just simply use the algebraic definition of subtraction to change it into an addition problem and get that it's equal to 5.3. So that's one thing we could do here to get to a result. And so since it equals 5.3, I can write that up here. Now I can write my minus and my plus, and it's 4.7 plus the opposite of A. Now we got something we can work with here and see whether we can figure out what A is. And again, we want to look at this addition and subtraction of things to come up with the answer that we are after. So 4.7 plus the opposite of A equals 5.3. So I need 5.3 minus 4.7 minus 4.7 equals the opposite of A. Okay, so we've got, let's see, 4.7 subtracted from 5.3, and that's going to be 6/10. 0.6 equals the opposite of A. Now, we're not done yet. We've been asked to find out what A is, not the opposite of A. So here we're kind of in this position. Well, how do we fix that? Well, we're going to bring in a little property that would help us to resolve this discrepancy, which is two ways to do this. We can multiply both sides of the equation by a -1. A -1 times 6/10 is a -6/10. A -1 times the opposite of A is A. Okay, it's a new property, and this is the multiplication property of equality. If we multiply both sides of the equation by the same value, all terms, we get an equivalent statement, an equal statement. The other thing we could do is we could add a negative, we could subtract 6/10 from both sides of the equation. We could add A to both sides of the equation, the addition property of equality. And in that case, we'd get A equals the opposite of 6/10. So here I'm going to go in and make this a -1 times 6/10. The opposite of A times a -1. A -1 times 0.6 is a -0.6. Negative times a negative is a positive, so that is A. A equals a -0.6. This is our solution to this problem. We needed to have been careful here about how we represented this. This wasn't going to fit into our addition math fact triangle in that form. Okay, those are the additional examples. We've got a little bit more here in this lesson I'd like to take a look at with you in the textbook, and then I'll cut you loose on the assignment. Okay, here we go. This is the end of 2-7, the special numbers for addition. We can get some of this from the math fact triangle, in which one of the numbers is 0. And there's two possible cases. Either 0 is one of the add-ins or 0 is the sum. 0 is the additive identity. So anything plus 0 is going to be equal to whatever it was to begin with. So if 0 plus r equals p, that's really coming back to tell us that r equals p. That's our additive identity property of 0. For any real number, a, that's just some number a plus 0 is equal to 0 plus a, which is equal to a. Remember this, 0 is the additive identity. If we add 0 to anything, it just stays the same. And this leads us to the property of how do we create a 0 in an equation. Sometimes it's useful for us, as we did with the math facts, if we add and subtract numbers, the same number, then we know that they are additive inverses or opposites, and if they're opposites, when we add opposites to each other, we get 0, and that's the additive inverse property. For any real number a plus the opposite of a is equal to the opposite of a plus a, and that equals 0. This gives us a way we can, in an equation, we can create a 0, which is an identity, and allow us to perhaps isolate something we'd like to. Just back quickly, I know I repeat this a lot, but rather than saying this, calling this negative a, call it the opposite of a, so you don't get confused if it turns out that a is a negative number. You want to remember the opposite of a. If a is a negative number, let's say for example a is negative 2. If a is negative 2, the opposite of a is 2, such that a negative 2 plus 2 equals 0. So the opposite of a plus a equals 0. That's what this property means to us. Do be careful about how you do that. It's a common mistake. If you state it this way, I believe you can avoid making that mistake and be successful with your algebra. Your assignment, cover the ideas applying the math. When you're done with it, come see me for your mastery quiz. You've got questions, remember, talk to your friends, ask people about it, see who knows what. There's a lot of knowledge in the room. If you still need help, put it up on the board. Give me some time to get to it, and I'll get over to help you with it as soon as I can. If you need more help with these math fact triangles, let me know. I can create a worksheet for you, give you some more help beyond what's being done in the assignment. Best of luck. See you on the mastery quiz.